Yes, this is E. Jyoti Kiranmayi, lecturer in Computer Science Department, working in SVD Government Degree College for Women, Nidadavolu. This lecture is all about polymorphism with static methods and private methods. First of all, we look at what is polymorphism and types of polymorphism, and then we'll see about polymorphism with static methods and private methods. Let us briefly look at what is polymorphism. Polymorphism is a Greek word derived from two words, and the two words are poly and morphs. Poly means many and morphs means forms. That means polymorphism means many forms. So in Java, polymorphism is expressed with one phrase, that is one interface, multiple methods. That means that in Java we can have variables, methods and objects that can exist in various forms and which can perform different tasks based on the context or depending on the context where we use them. So this allows the programmer to write flexible code wherein same variables and methods can perform different tasks. Types of polymorphism. Polymorphism can be classified into two types: compile time polymorphism and runtime polymorphism. Compile time polymorphism is also known as static polymorphism, and runtime polymorphism is also known as dynamic polymorphism. And compile time polymorphism can be achieved through method overloading, and runtime polymorphism is achieved through dynamic method dispatch. Now we'll see polymorphism with static methods. Methods that are declared with static keyword are called as static methods. Static methods belong to class rather than objects of the class. So therefore static methods are called as class methods. So that means that only one copy of the static method exists in memory, and that copy is shared by all the objects of the class. Because static methods are class methods, they are accessed by using name of the class and dot operator. No need to wait till the creation of objects. So therefore static methods can be accessed even before the creation of objects. Overloading of static methods. Just like normal methods, static methods can be overloaded. That is, in a class we can have more than one method, more than one static method with the same name, but the methods must differ in their parameters. The methods must differ in terms of type of parameters or number of parameters or order of parameters. Then those methods are said to be overloaded. One important thing is, if the methods differ only by static keyword, then those methods are not said to be overloaded. And static methods are class methods, so Java compiler need not wait till the creation of objects, and the method calls are bounded to method definition at the compilation time itself. Therefore static polymorphism or compile time polymorphism can be achieved by overloading static methods. Let us see an example for overloading of static methods. So we have a class here, name of the class is polystat, and then we have a method here. Name of the method is show, which is of type static. So this is a static method, and this method is taking one parameter, that is int x, and this is printing the value of x, system.out.println the value of x is equal to x. And then we have one more method, and the name of this method is also show, and this is also static method, and this is taking a parameter which is of type string, and this is printing system.out.println the string variable yes. So in this class we have two methods, so name of the two methods is same, that is show, and then both are declared as static methods, but these methods are differ. These methods are taking different parameters. The first method is taking integer parameter, the second method is taking string parameters. So these methods are said to be overloaded methods. Now so we have a main method here, public static void main. In this main method we are calling the show method, because the show method, both the show methods are static methods, so static methods are class methods. So that is the reason why we are calling this show method by using the name of the class polystat dot show. To the first method call we are passing the value 10. uh, because we are passing an integer value, this method call will invoke this method definition that is taking integer value, and it will print the value of x is equal to 10. So when we execute this output, you will get this statement, the value of x is equal to 10. And then in the second statement, we are calling again the show method, polystat.show. This time we are passing a string. Because we are passing string parameter, it will invoke this method definition, which is taking string parameter, and it is printing the string that we have passed. System.out.println, we have passed Java, so it will print Java. That means here, so we have static methods here, and we are calling those static methods by passing the parameters. Here the method calls will be bounded to method definition at the compilation time itself. Why? Because these are class methods. So this is an example for compile time polymorphism or static polymorphism. Overriding static methods. What is overriding? When a subclass redefines a method of superclass, then it is called as overriding. In case of static methods, when static methods are overridden, that means that when a subclass redefines a static method of superclass, then the JVM decides which method to invoke depending on the type of the reference variable rather than the object to which it is pointing to. So this is in case of static methods. Static methods are class methods, hence method calls are bounded to method definition at compilation time itself. So therefore, static polymorphism can be achieved through overriding static methods. Let us see an example for overriding static methods. So here we have a class here, name of the class is base. In this class base we have a method, name of the method is show, and it is a static method. So this method is displaying a message system.out.println show in superclass. And then we have one more class derived extends base. So derived is a subclass and base is a superclass. So this derived class is actually overriding the method of the superclass, that is a show method. So static void show, this is also printing a message system.out.println show in derived class. And then we have a main method, public static void main. In this main method, we have created a reference variable to superclass, that is base OB is equal to new derived. And then so ob.show, by using superclass reference variable, we are calling the show method. So when we execute this program, so we'll get this output show in superclass. That means that here when you are calling show method by using superclass reference variable, it is invoking the method of the superclass. It is not invoking the method of the derived class. Why? Because at runtime, so JVM will see the type of the reference variable rather than the object to which it is pointing to. Here the superclass reference variable is actually pointing to the subclass. But when it is invoking the method of the superclass. Why? Because OB is of type base, which is the superclass reference variable, and this method call is bounded to method definition at compilation time itself. So that is the reason why this is an example for static polymorphism or compile time polymorphism. Next one is polymorphism with private methods. What are private methods? Methods declared with private access specifier are called as private methods. Private methods cannot be accessed outside the class. That means private methods can be accessed only within the class. So like normal methods, private methods can be overloaded, but they should be accessed within the class only. Let us see an example for overloading private methods. So here we have a class here, name of the class is polyprivate, and then we have a method here, name of the method is show, and it is a private method which is taking one parameter int x, and it is printing the value of x. The value of x is equal to x. And then we have one more method, and this is also private method. Name of the method is also same, that is show method, but it is taking a string parameter, string s, and it is printing system.out.println s. So in this class we have two methods. The name of both the methods is same, that is a show, and both are private methods, and both the methods are differ in terms of their parameters. The first one is taking integer parameter and the second one is taking string parameter. So both methods are overloaded methods. Now we have a main method. In this main method, we have created an object for poly private class. Poly private ob is equal to new poly private, and then by using this object we are calling show method. When we are calling show method, we are passing a 10, that means integer value, so it will invoke this, the method which is taking integer parameter. And then again we are calling with the same object, we are calling show method. This time we are passing string, so this will invoke the method that is taking string parameter. Now when we execute this program, we'll get this output. So for the first method call, you'll get the value of x is equal to 10, and for the second method call, Java will get printed. The first method call is bounded to this method definition, and the second method call is bounded to this method definition. And these method calls are bounded to the method definitions at the compilation time itself. Overriding private methods. Private methods cannot be overridden. Why? Because private methods are invisible to subclasses. That is, private methods are not available in subclasses. Even if a method in subclass is same as that of the method in superclass, then those methods act as different methods. That is, superclass will have its own copy and subclass will have its own copy. So it will not come under method overriding. So therefore, private methods cannot be overridden. Let me briefly summarize what we have learned in this lecture. In Java, polymorphism allows variables, methods, and objects to take different forms at different instances to perform various tasks. And then static polymorphism can be achieved through overloading and overriding of static methods, as well as through overloading private methods. So these are the important points that we have learned in this lecture. These are the references. Thank you.